Saxon Advanced Mathematics, lesson 49. It's a two-parter, but really the first part is the only part that's juicy. But before I say anything else, let me say Happy New Year. Welcome to 2022. I hope you're enjoying it so far. If you took a break with me, whether you celebrated Hanukkah, Kwanzaa, the solstice, Christmas, or anything else, I hope you enjoyed that. But we all flipped our calendars forward and we're all in the new year. So yay, team. Here we go. Remember that you did not have any homework over the break. So as of today, or whenever you're watching this, you don't have any homework due right now. These next 4 lessons that I'm going to teach you this week, that homework will be due next week on the 10th. So that's why I say no homework due, and that's why I get to cross them off as I teach them, and you cross them off as you do the homework. All right, this lesson I want you to put into the bedrock of your brain. I know exponential functions can be a little confusing. I know that the connection between exponents and logs can wobble, and we haven't even talked about log functions before, so that's going to be a new thing to you. But they're closely related, and I want to build this as kind of like a bedrock into your brain. So let's start by looking at exponential functions. And when I say function, I'm just talking about, let's draw a picture of not the equation of a line, but the curve, if you will, of an exponent, right? What's the picture that it makes when you graph an exponent? So let's take a specific equation where the number equals 2 raised to the power of the log, right? So that doesn't necessarily mean anything to you. Let's draw a graph and let's make a chart, right? Now, just like any other time that we graph, this number is going to be our independent variable. We're going to start with that one. That's the one that's kind of buried in an equation, and we can pick whatever we want. We'll calculate by putting that number that we choose on as a power of 2, and then that will give us our dependent variable, or our n. Now in graphing, the convention is that we put our independent variable on this axis. We've been doing this all along, so you probably are like, what are you even talking about? But it's a thing. Remember, L is the log, and it's also equal to the exponent. And up here, we'll have our n, which is our number. Just to remind you of this. All right, so let's pick some values here that we think will be pretty easy to calculate. Whenever we're taking a value and putting it on as an exponent, I'd love to choose 0. This is 2 to the 0, and that is 1. Holla, that's good. And we know that's an important number on an exponential function. Let's go on. What about the power of 1? 2 to the first power is 2. Okay, let's go up to squared. 2 squared, that would be 4. Now my numbers are starting to get a little big, so I would like to back off. Let's try a few negatives. 2 to the negative 1 would be 1/2. And this is going to get kind of squeezy here. I'll put it up. Let's just try another big one. 2 to the third power is 8. Okay, so let's graph these on here and see what we get. 0 and 1. We know that that is that special point that always shows up on exponential functions. That's what we're looking at right now. It always shows up here. If this number, did I do this with you guys or did I do it with the other class? That's a good question. But I'll just tell you, this point, unless we get a really fancy function, this point is always going to be an important turning point for our exponential function. On this side, it will go up in an interesting pattern based on the base. Over here, it's just going to peter away and become an asymptote, right? Oh no, you guys are the ones who learned this. I'm sorry. I thought I was still in Algebra 2. So we know because this base is greater than 1, this is going to go up. These values will help us. We know this one is just going to crash and burn, right? If this base was a fraction, then it would be reversed, wouldn't it? And we would be going up over here, and this would be the crash and burn. All right, let's graph the rest of these. 1, 1 and 2. I'm using the blue lines on this side. I guess I could put them in for the purpose of keeping your head on straight. 1 and 2, 2 and 4, 1, 2, 3, 4, and 3 and 8. 1, 2, 3, 4, 5, 6, 7, 8, right? And then we connect the dots, and there we have our cute little exponential function, right? Now what we're going to do is we're going to do the log function of the same relationship. In this case, the way log functions work is we're going to say the log, or the exponent, we're going to graph these in the opposite order. Here we started with the log, or the exponent, as our independent variable, and we calculated to find our number. Here it's vice versa. The independent variable, the one that we choose, is the number, and then we'll back into that to find what's the exponent that you put on 2 to get that number. Do you see we're switching around the values? And let me draw the picture for you. I'm going to draw this one slightly higher. In this case, n is our independent variable. Last time, n was our dependent variable. L is our new dependent variable, and before that was the independent. So what we're doing here is we're flipping the axes. The information that was on the x-axis last time is now on the y, and the information that was on the y last time is now on the x. That's a little mind-blowing, and it's going to change the shape of our picture. Let's make ourselves a chart so we can calculate some of these values and take a look at what's happening. We'll be choosing our n's, and then we'll be plugging it into that equation and coming up with the logs. Now, what's cool is we can kind of use these numbers to help us go backwards in this equation. So let me show you what I mean. If the number is 1, then that's a 2, sorry. What is the exponent that we put on 2 in order to get the number of 1? Well, it's 0. And I'll write this out. Okay, this is what we're asking ourselves. What is the exponent, or log, that we put on a base of 2 to get the number of 1? 2 to the 0, right, equals 1. That shouldn't really be equals. That's just what my brain is thinking about. All right, notice it's the reverse of that. Okay, let's try 2. So our number is 2. What is the exponent that you put on the base of 2 to get the number of 2? That would be 1. See how they're giving us backwards results? That's not a coincidence. Let's choose the number 4. What is the exponent we put on the base of 2 to get the number 4? Oh, that's 2, right? 2 squared would give us 4. All right, let's try this 1/2 and see if we can get our brains to do that. What is the exponent we put on 2 to get the number of 1/2? Okay, we have to flip that 2 down to the denominator, so that would be -1. Oh my gosh, it's working, even though it's totally, it feels backwards and somewhat crazy, but we're always going to have this pattern between the exponential functions and the log functions. The input of one is the output of the other. The output of one is the input of the other. And our last one, what if we want the number to be 8? What's the exponent we put on 2 to get the number of 8? Well, that would be 3. Okay, so let's graph these now. Oh, I drew this wrong. Let's Let's see if I can fix it. Yes, I can. 1, 0 is our first point. I want to graph this on the next page. So you keep this. I've got this in my notes. This is how I want to draw the graph of a log function. It's this way. Instead of focusing on the first and second quadrants, okay, this is first and second quadrants. With a log function, we want to focus on the first and fourth quadrants. You'll see why in just a second. So let's graph them. Our first point was 1, 0, but let me put my little markies in. You can do it too. All right, and remember this is our N and this is our L. N is the number, L is the log or exponent. On our chart, the first point was 1, 0. So we go to 1 and 0. Do you remember how, and I've got the picture, I've got another picture right here. This is our exponential function. Do you remember how I said this point, remember, is always the turning point, this point 0, 1? Well, guess what? We have the same kind of magical turning point here in our log functions of 1, 0. Here it's 0, 1. Here it's 1, 0. Oh, but it behaves in the same way. Our points will asymptote down on this side, which we know because we know that if this number is 1/2, it's -1. That's another one of our points, isn't it? So we can see, oh yeah, this is the asymptote side. This is our crash and burn. And now we'll have something more interesting going on up here. If the number is 2, the log is 1. If the number is 4, the log is 2. And if the number is 8, did we do that? I think we did. 1, 2, 3, 4, 5, 6, 7, 8. Then the log or exponent is 3, right? Because 2 to the third power is 8. So there's the relationship. So look what happens. In a log function, it's got the same information, the same relationships as an exponential function. Here, these notes show it nicely together, right? In an exponential function, the curve comes up out of the second quadrant, crosses right here at 0, 1, and then springs up here. In a log function, it's coming from down here in the fourth quadrant. It crosses here at this point, and then it springs that direction. Interesting, right? And so there's a very close relationship between these two. It feels like log functions are crazy and wicked and wild and are here only to make us feel like we got hit by a tornado, but they're actually just another way of looking at an exponential function, right? The function describes the relationship as we've written it in the equations, and the equations are like inside out of each other. They're kind of like inverse. I don't know if that's technically correct. But in any case, notice that this shape is very distinctive and it's going to stay true in our explorations of exponential and log functions. Exponentials will always take this shape, logs will take that shape. That is all you need to know today. All right, and then part B of this, John feels that it's important to develop for you the law of logarithms and show you how you can do that too. But I don't think he asks you to do that in the homework. Oh yeah, he does, number 8, but you won't be doing that one. This is not important to me, so all I'm gonna do is show you the law of logs again and make sure that you get these well into your brain. Okay, this is saying that if you're multiplying two numbers together for your argument, you can separate them out and add them and you'll get the same answer. Likewise, if you're dividing, you can separate them and subtract. And then this one, remember this is like the product rule and this is like the quotient rule. This one is the weirdest. If you're raising your argument to a power, you can pop that exponent off and write it as a coefficient. And remember that it's true of our rules for exponents. We can go in any direction in these equations, right? We can go from this side to that or that side to this. In our rules for exponents, we usually go in one direction. Oh, you hear what I just said? But they're on hiatus, but we're not. But in the logarithms, we tend to go both ways, if that makes sense, especially this power rule. We can pop that off if we want, and we can also put it back on if we want to. So these can be used to simplify going in either direction, if that makes any sense to you, right? And you're fully invited to do that. All right, guess what? That's the end of this lesson. I hope that your brain feels okay. It's kind of a process to get back in the groove, isn't it? So if you've just come back from a break, figure it's gonna take you probably most of this week to feel like you're back up to cruising altitude. All right, that's done. Remember, we're still skipping those concept review problems. We don't test that way anymore. The SAT has changed. So there's no need to do those. And I'll see you next time for lesson 50. The topic is trig. I'm pumped. Goodbye.